Okay, let's get started. So, in last class, we learned about KNN algorithm. So, a lot of things, how the algorithm essentially works, as in there is no training. Okay, so when you give the data points, when the data points are generated, it only keeps a tab on distances, and of course, various distances are there. So, the moment you do a data dot fit, sorry, the model dot fit of data, immediately all these calculations are done with respective k value. Okay, again, k value is something that you have to calculate and provide to the model won't know. So k value is calculated before the fitting the model. Okay, you will determine k value using the cross validation score. Now during inference, what happens is, as the new data point comes, because the model has already learned the distances of various data points, so it will start calculating distance from new data point to the old data points. And again, depends on the classification or regression kind of problem. For classification, it only considers the least distances based on the k value provided. If you provide k value as 5, it will consider 5 smallest values, k value 3 smallest distance. Basis on that, it will identify the class. Okay, and how it's gonna identify the class? It will only gonna look at the classes of the already identified data points, those 3 data points, and majority, whichever is the class, it will assign the class. And regression also, for regression, what it will do, it will just simply take the regression value of those 3 data points divided by 3 and assign the k value. So this is how k values are, the KNN algorithm works. And to determine k value, we use the cross validation method. And cross validation, again, we'll learn in depth about what cross validation is, how it works in when we discuss evaluation metrics. But for now, just understand the cross validation is a method wherein which you basically keep training data set, validation data set, split them into separate percentages, like 80% training data, validation 20%. And now the difference here is cross validation. You will start considering 4 examples of training with 1 example. You will merge randomly 4 examples of train with 1 example of validation and start doing the training process. That's how cross validation works. Okay, so basis on that, you will, wherever cross validation is highest, you will pick the k value. Okay, remember cross validation score for KNN, because k means also use very similar methodology. Okay, but it is little slightly different there. So you might get confused, because this is also saying KNN and there it is saying k means. So k is common, so people get confused. Okay, so for KNN cross validation score, k means clustering, we have elbow method, we have silhouette score calculation, all of those things. Anyway, so talking about KNN, there are certain assumptions. For example, feature scaling has to be done, dimensionality has to be, lower, because there is curse of dimensionality here also. And again, the nature of data, for you have to pick the calculation metrics according to the type of data. So, and assumptions are also there. Data feature homogeneity should be there, which means everything should be on the same scale, represent same type of data. 2 rows cannot have different scales. Okay, so that is one. And distance metric that you choose should be relevant. Even locality of the data is another assumption, which means data points should be closer to each other in the feature space. So sufficient training data, independence of instances, that means no duplicate rows, or not even two rows should not have the same correlation or something like that. Okay, they should be independent. So balanced class distribution, that means 2 classes that we are trying to classify should have 50-50 balance. And there is curse of dimensionality, very important. Okay, so you can't have too many features. You can't use KNN on 100 features problem, or even 30 feature problem. That doesn't make sense. Okay, so that is assumptions, advantages, disadvantages we discussed. You can have a look at it. The most problematic one is the first two ones. This, as a result of this, okay, we don't use KNN in general. If the data set is large, you don't use KNN. Don't try to use also, doesn't make sense, because you won't be able to scale it. Scalability will become a problem. Okay, so if your data set is smaller, then you can use it. Okay, moving on. So we were discussing, so previously we were discussing, I think we started working on one of the use cases. Okay, for example, we have to predict the average rating. Why we have to predict is a separate question. Okay, why we have to predict the rating is a separate question, but for now let's assume we have to predict the average rating. So in that case, this becomes a regression problem. Average rating is a floating value, so we have to predict that floating value. So for that, we have data on restaurant ID, name, country code, lot of text based information is there, longitude, latitude, okay, cuisines, and the average cost of two, and then you have currency, and then some features, whether there is a table booking, whether there is online delivery, whether they are delivering now, okay, price, average range, and aggregate rating, already existing rating, okay, rating color is there, excellent, voting, country, so basically Philippines data. Okay, so basis on this, we have to predict the average rating. Now a lot of the features, according to me, we have to do severe, heavy, if not severe, heavy feature engineering here. Okay, because a lot of the features are text based features. So what you're gonna do is, you're gonna first analyze the data. You're gonna look at the cuisines. If you group by cuisines, then you can see price ranges. Again, this is from 1 to 5 values, so you can look at the average cost of 2 and price range. Okay, aggregate rating is there, and how many votes are issued. So for various cuisines we are gonna look at. Again, if you look at the city wise, okay, okay, this I think looks like there's a mix of data worldwide, okay, for Zomato. So according to city, if you group, then you can see the average rating here, price range, okay, average cost, latitude would be the same city, latitude and longitude, basically in that city where that Zomato restaurant is located. So that's what this is. Country code, you can safely ignore. If you are using city, you don't need country code. And likewise, you're gonna look at basis on the how many, basically you're trying to see how many Zomato restaurants are there per country. As you can see, data is highly imbalanced. India has the highest number, and next UK, and everywhere else there are less number of restaurants. Okay, likewise you can look at the city in India. Where is the Zomato highest located? Is in New Delhi. Then comes Gurgaon, Noida, okay, which are closer by to Delhi anyway. Faridabad, okay, then comes the rest of the cities. So top 10 cuisines ordered by Zomato are like North Indian. Basically you are doing only group by. Okay, there is nothing fancy about in this code. Okay, very simple code only, just you're doing a group by, and you're plotting that cuisine data. Okay, cuisine data, you're sorting it and taking the top 10 and plotting the same top 10 here. So don't worry about the data, so you can generate these plots very easily. Now these days you are also required to use code assistance. That also we'll talk about in next class, or next to next class. Hopefully I will have to set up that environment. I will show you how to use coding environment to write the code fast, because that will become the norm going forward. Okay, going forward you won't be writing all this code by yourself, by remembering or by taking from Stack Overflow, but rather generating the code anyway, and that's a different thing. So we are just analyzing the data. Top 10 types of foods are North Indian, Chinese, okay, fast food, etc. So all of this you are analyzing. After you analyzing, you are also looking at how many of them have online delivery, and some of them don't have online delivery, so that also you are analyzing. And finally, after you analyze all this information, now you're gonna start working on your model. Okay, before that, in the reviews, because you're gonna predict the average rating, you're gonna look at the which is the number of maximum occurring word in the reviews. Okay, so for that we have something called word cloud. Okay, you have to pip install this word cloud, and from that you can also remove the stop words. Stop words are, again, we'll talk about this in depth. Let's just say there is a sentence called a man goes to a restaurant to eat food. Okay, so if I am to um, so what stop words means? Stop words are the words that do not essentially add any meaning to the sentence, no inherent meaning, but rather they are connecting words. For example, a to. So these are nothing. I could, if I go and say, if I say this much, you will still be able to understand what I'm trying to say. Man, restaurant, eat food. Okay, it essentially says man might have, you would instantly understand. Maybe the man went to restaurant to eat food. Okay, so whatever the words that we removed, okay, those are called as stop words. Stop words are nothing but the words in a review or in a word corpus which do not add additional inherent meaning. Okay, we have to remove stop words. That is a very common pre-processing step when you work on text data. When we deal with NLP, we will be doing that only. We will be doing that as one of the steps in pre-processing. We will talk about it in natural language processing, but for now, understand stop words are the words that don't add any meaning, and we have to remove them. And once we remove them, then we can run the word cloud. Okay, don't worry about how this thing works for now. I will, again, word cloud also we will talk about it in NLP in depth. For now, understand word cloud is a function written that such that it's a class from which it offers a lot of functions. Okay, so generate from frequencies is the method that will look at certain column, and basis on that column it will pick the most occurring words. Okay, underneath it generates bigram or n-gram, whatever. We will talk about all of that in NLP class. For now, just understand word cloud will allow you to call this method. Using this method, you can pass a column, and using that column you can look at, inside that column you can look at most occurring words. So most occurring words is Domino's Pizza, Subway, Cafe, Coffee Day, and then you have green chick chop. So whichever is bigger in size is the most occurring word. Okay, Haldiram's Barbecue Nation. Why do we have to do this is the question. Very simple. If you are a restaurant owner and you want to open a restaurant, first you have to analyze which ones are giving more revenue, which ones are generating more revenue. If you want to generate revenue for yourself, you'll have to open very similar type of cafe, right? Similar type of restaurant. That is why you do this word cloud. Okay, so this was again one of the interview questions long back was asked to me. Okay, long back, many years back, I remember. So this is why you have to do it. Once you generate the word cloud, let's just say you generate the word cloud on 10,000 rows of data, and you are working with certain franchise, you immediately know what is going to sell. For example, I can open a cafe or offer coffee or coffee day, something like that. Subway items, I can have similar food items from Subway or Domino's Pizza, I can offer whatever. So basically we'll get some idea. Anyway, so moving on, so we can determine the maximum number of restaurants associated with Zomato. Okay, followed by Domino's Pizza and a green chick chop. So that is what you have found out. Okay, most ones are Domino's Pizza and green chick chop. Okay, whatever this is. Okay, now you're gonna analyze the rating. If these are the most ones that are selling, then what is their rating? That is the use case, right? We have to predict the uh, rating. Then what is their rating? Okay, that is what we are gonna predict. So basically we are gonna look at the number of votes, average cost of two, how much, um, what is their relationship. Basically, if you increase the price, average cost of two, if you increase, your rating is gonna falling. Number of votes people are voting are less. Okay, if you reduce the price, okay, here as you can see, lot of ratings fall here only, lot of votings. People who have chosen to even give a vote or review have increased based on the price. That means you have to get your price down. That is the very clear answer here. Okay, likewise you will start looking at the correlation, basically which features are helping me do the prediction. So average rating is directly correlated with price range. So that is what we observe here also in this plot. They are directly related. Okay, rating versus price range. If you basically, if you look at the relationship here, it's going in the positive direction. Okay, another interview question is, what is the range of this Pearson correlation that you measure? It is 1 to -1. Remember that. Okay, so here if it is positive, what we are essentially saying is, if I offer the menu items for less price, then people will be willing to give me a rating. That too positive rating. That is important. Positive relation means positive rating, and number of people leaving the rating is also increasing. Okay, and average rating is also increasing. Okay, so this way restaurant ID is useless. You have to remove it. Restaurant ID, country code are useless pretty much. These two features should not be considered. Okay, ignore these two. Next is longitude, latitude is also something you should not consider, useless. Okay, useless for, I think longitude and latitude still make sense, because based on the location also you can get the good amount of rating. These are still fine, but I think I will not want to consider country code and restaurant ID. Okay, so this way you can decide for the correlation. You can drop these two. Okay, basis on longitude and latitude, you can probably have the location name instead. Okay, that way also you can do average cost. So basically you are doing the correlation analysis here, trying to understand which features are contributing to me in a positive way, which ones are contributing negative way. Once you have all this information, now you have to build the model. Now to build the model, so a lot of your features were text based features, so that's why you are doing the one hot encoding. Get dummies will do the one hot encoding. Okay, so we will have one separate class for feature engineering. Okay, there we will discuss what are the techniques and why. Most importantly, the question why is something you have to understand. Why we are doing this one only, why not the other one? So that we will talk. That is why I have kept this feature engine. I'm simultaneously working on this feature engine notebook separately. Okay, so I will once I have the notebooks ready, I will talk about all these feature engineering steps that we have to do. Anyway, so up until that point, get dummies means one hot encoding. Okay, so we are doing the one hot encoding, split, nothing but splitting the features into numerical numbers. Okay, so once you do, the next step is we have to identify k value. Even before we fit the data, we should know what is the k value. So for that, what we have done is we have run up to 1 to 50 range. This much range is not necessary. You can run it up to 1 to 20 or 1 to 30 max. Okay, but for the sake of running, so we have run it. So after running 50 different k values, we have fitted the model, we have predicted and calculated the accuracy. So nothing but we are determining for which k value we are getting the best accuracy. So it turns out for this specific problem, KNN is not at all a good algorithm. But anyway, because we are trying to understand how the algorithm works, from that point of view, as you can see, the max accuracy is obtained somewhere here, 56. Okay, 56 value. So the max value of k for which it is working is, I believe, 7. Okay, here I have tested with 6. but somewhere here there should be 7. Okay, I think I ran multiple runs, that's why I have changed the value. But if you notice here somewhere it is 7, this value is 7. Okay, for 7 value you are getting, let's verify that. Maybe 7 is 52. Okay, 13. Okay, so in this case you're getting 13. Okay, um anyway, I did this few weeks days back. Okay, anyway, fine. So for k value 13 we are getting the best value, and we are also going to calculate the r squared error, r squared. Okay, r2 sorry, r squared error. Okay, so once you calculate that, basis on that you can say which is the best uh, best k value, and then you have to redo the process. One, basically the first step is to determine the k value, and then once you determine the best k, then you have to refit the model with that k. Once you refit the model, then you can do your prediction. Actually I have used only r2 squared here, but you should measure multiple evaluation metrics. What are those metrics, we'll talk about in just a little bit time. But as you can see here, using that we are predicting average cost for 2. Okay, here you are doing average cost for 2, and here you are doing the where is the rating? Okay, so what is our y test? Okay, y test is average cost of 2. All right, so I think we are not predicting the rating, but rather we are predicting the cost. How much cost is gonna be per for a couple, basically for 2 people. Okay, that is what we are predicting. So basis on that, as you can see, actually in this case I think we are measuring multiple things. That is what my understanding is, because here y cost of, anyway, I must have repeated the same steps, but don't worry about it, but just understand the flow. So basically you determine the k value. Okay, then you calculate the final metrics. Okay, so basis on this we can say, basically you can see here for value of 6 here, r squared error, r2 increased up to certain point, and from their point it started decreasing. This is a bad model. That is what I can infer from looking at it. Ideally it should be like this. Okay, it should increase at certain point, and from there on it should decrease, which it is doing, but then it's not going till 0.9. That is the problem in this plot. Okay, so in this plot, how do you understand this? R squared error versus root mean squared error. Okay, this is not even making sense, because root mean squared error, when the root mean squared error was low, r squared was high, which is what it should be. Okay, lower the root mean squared, but what is not making sense is this root mean squared is high. Okay, so it should have started from very low value. 11,000 is high value. If it was a squared error, then 11,000 I would still have accepted. But for the thing that you're trying to predict, what are you trying to predict? You're trying to predict the cost of 2 people. Cost of 2 people should be somewhere between 100 to 500 rupees, or maybe 1000 rupees. Okay, so that means if your root mean squared error itself is like 11,000, this is a bad model. It should be closer to the actual y values, which is 100 to 1000. Okay, in that range, what is your r squared? That is what should have been the case, but looks like KNN is not the right kind of algorithm we should use for Zomato problem. Okay, but anyway, because we are trying to understand, we are using it. So anyway, let's moving on. So this way you can predict the cost. Okay, so accuracy also you have measured, but accuracy is not good enough. 67% is not good enough, I would say. And RMSE is also very high, which is not good enough. R squared is also very high. Okay, R squared is low. 70% of variance is captured, but that is not good enough. Anyway, so this is how you can use the KNN for regression problem. But now, as you're learning the model, you also have to be one key thing about data science is explainability. You should be able to explain. But for that to be able to explain, you should know what to explain. Correct? So here we will briefly talk about regression metrics. Okay, the first thing I want to talk about is residual, and this applies to all regression models. By the way, I want to talk about residual. Residual is nothing but, although the graph you are seeing here is a plot of linear regression, but residual is nothing but how far away is the actual point from the best fit line. That is the, in case of linear regression, that is what residual is. But for other algorithms, you can understand it in very easy way. That is how far away is your predicted value from your original value. That is residual. That means if I open a cafe bar, oh sorry, not bar, cafe store, if I sell each coffee for 200 rupees, let's just say the previous owner, I overtook the previous owner's cafe, he was selling it for 200 rupees. Now if I am to reach profitability, okay, let's just say I'm selling it for 250 rupees. Now my model is saying, okay, I'm selling for 250, previous owner sold for 200, but my model is predicting I have to sell it for let's just say 350. What is the difference between 350 and 250? 100. That 100 is the error. That means on an average my model is saying, sir, you're selling all your products for low price, on an average you're selling it for, underselling for 100 rupees. Okay, and that 100 is the error message, because previous owner was able to sell it for 200, I'm planning to sell it for 250. Okay, so the error became, are you following me what error means? Error means the model is going out of the way, making miscalculations by so much amount. So that is what the error is. Did you understand this residual? Okay, all right. So between error, you have to pay attention here, between error and the next matrix is mean absolute error. Between residual and mean absolute error, there is small difference, but they are very similar. Residual is, notice y minus y cap, but it is not talking about average. That is one. Second thing is, residual can be more, or it can be positive, or it can be negative. My model can say, make the error of, the model can say, okay, you have to sell them on an average for 350, or it can also say you have to sell on average of 150. So the error is plus or minus. Okay, it's in plus or minus range. Error, okay, we call it residual. But mean absolute error is not like that. It is never positive or negative. It is always positive. That means if residual says you have to sell it for, let's just say 350, or it may say 150, which is ideally going like 100 to 150 points from 250. But mean absolute error will say that on an average, okay, your model is predicting 50 points or 100 points away from the original value. See, in order to see, if you read it, they may sound exactly the same, but they are not the same. So here mean absolute error is calculated. So initially the error is calculated at row level. Okay, residuals are calculated at row level. As you can see, Jan 17th, for this row it is calculated here, for this row it is calculated here. So the residuals are calculated for each and every row. Once you calculate the same residual error, you take the average and positive value of that, then that becomes mean absolute error. Mean absolute error is calculated for the entire data. Average residuals for the entire data set will become mean absolute error. So if I say, okay, if I open a cafe at a certain location and start selling the cafe for coffee for so and so price, I may incur plus 50 or minus 50 profit or loss. That is error. Okay, mean absolute error is, okay, the same sentence. If I open a cafe at a certain location and start selling the coffee for certain price, then on an average I will incur 50 rupees of loss per coffee sold. That is mean absolute error. Notice the difference. Am I clear? Am I making sense? Are you understanding? Okay, that is mean absolute error. That is a slight difference. Next is mean squared error. Now mean squared error is you're gonna square it up. So now you're not gonna talk about see, mean absolute error is one coffee shop, one coffee item. Now you have to square that. Okay, so let's just say you talk about more coffee shops, more items, coffee items, then you're kind of squaring it, although it's not the exact thing. But if, let's just say, instead of selling two items, now you're gonna talk about four items. Okay, actually I'm squaring the items, not the error itself. That's not the right analogy, but just to make you understand. Okay, earlier you are incurring on a per item, you are incurring 50 rupees of loss or profit. Okay, but now because you squared it, you're gonna say, if I open four shops in four locations and start selling four different types of coffees at so and so amount of price, then I'm gonna incur so and so amount of loss. So you basically, you're squaring the error. Okay, so that you have to understand. So it's the square difference. Now root mean squared error is very similar to absolute error. Okay, there is one slight drawback with mean absolute error, which is why we prefer using root mean squared error. Okay, mean absolute error, although it's preferable, okay, root mean squared error is used because what happens is, in case you bring outliers, okay, then your mean absolute error will completely give you wrong value. Okay, for example, let's just say you have taking this Zomato example only. Let's just say Zomato has opened 1,000 coffee shops in the country, in whole of India, but there are 10 coffee shops which are selling the coffee for 1,000 rupees. Okay, which are outliers. Doesn't make sense. Or maybe 500 rupees, let's just say, for realistically. Okay, 500 rupees they are selling the coffee for, and some shops are selling for only 100 rupees, or not even 100. Let's just say they are selling for 40 rupees or 50 rupees. There's a huge variation. Now those 10 data points are gonna change your mean absolute error. Why? Because you're considering the average of all those residuals at row level. That means for 1,000 rows, you're calculating the average. Those 10 rows are gonna shift your average. They're gonna shift your mean. That's the drawback with mean absolute error. This is again one of the interview questions. Okay, mean absolute error has a impact of outliers in its calculation. Mean, when you do the mean and you consider the outliers shift the mean. Okay, so to mitigate that drawback, what statisticians did is they very cleverly said, okay, let's not use mean absolute error. Let's do one thing. Let's square it. Let's square all the data points and then take the square root. That way, most of the impact of outliers will be reduced. Okay, although it will not be completely reduced to zero, but it will be reduced by considerable amount. So we consider root mean squared error. This is very similar to mean absolute error, but we are squaring it and taking the square root. So basically, if there is one data point which is selling for 500 rupees, 500 into 500, okay, square root of that would be, but you are not taking the square root for only one data point, but when you combine it with lot other 999 data points together, the impact of 500 is reduced by a lot. Okay, so that's why they prefer root mean squared error. So root mean squared error also, if you have to explain, you have to explain very similarly to what you explain for mean absolute error. So nothing but, if I open a coffee shop at certain location and start selling coffee, on an average I might incur a difference in price from the original value by 50 or 100 points. Notice I said 50 or 100 even though I considered 500 data points. Okay, 500 as was some of the data points. I'm still saying 50 or 100 data points because the impact of those outliers is reduced. Okay, this is how you explain root mean squared error. Now max error, the worst case scenario. If I open the coffee shop at certain location, the worst loss that per item, okay, very important, per item I may incur is or overall error, because you notice the max error you are calculating at entire data set. So on yeah, this I think has to be on an average, because you can't consider overall. Let's just say per item on an average I am incurring is 10% here, in this case 0.1, but let's just say in our case 100 rupees. So I have to increase the price of the item. Okay, max error is the worst case scenario. Okay, so this way you have to explain this. Next is R squared, one of the top most asked interview questions in regression metrics is R squared and adjusted R squared. You have to understand these better. Now R squared is, very interestingly, R squared doesn't measure anything here like what it calculates here, but rather it measures the variance. So what R squared saying is, if you took 10 features to predict how much your coffee shop is going to sell your coffee for, okay, 10 features, then how much of those 10 features are capturing the variance? Nothing but R squared explains variance of independent variables on the target variable. I'll repeat again. So R squared explains the variance of independent features, nothing but all your columns that you have considered, on the target value that which you are trying to predict. Okay, so this is R squared. So it's a ratio of SSE and SST. SSE is nothing but your residuals only, squared residuals. SSE is nothing but the sum of squares of difference between actual and predicted value. Nothing but fancy word to say. Here we are saying mean. If you remove this mean and only consider squared error, that is what SSE is. SSE is the squared difference of values between predicted and the original value. SST is the total average, total error, total sum of squared of the difference between actual and the mean of the actual. Very important here. This is change. This is the difference between the SSE and SST. SSE is saying, okay, on an average we are going to square the actual value and predicted value, take the difference, and that is SSE. But SST is The mean bar indicates the mean of the same original values, not the predicted values. Okay, so when you take that ratio and subtract from 1, you will get r squared. R squared will explain how much of variance is calculated or explained by the model. Explained by who? Explained by the model. R squared is the variance explained by the model, of which variance of what? Variance of in of dependent variable explained through independent variables by the model. This way you have to convey the message. Nothing but if I'm going to open the coffee shop, I'm going to do the prediction of the coffee price, okay, and the features whatever I have considered. In our case, longitude, latitude, and then we have considered uh, some other features also you can consider, like shelf life of the coffee, how many employees are working, how many good reviews are there. Okay, so cost of cost per couple, okay, two for cost per two items or cost per two people, whatever. So different features, how much of those features are relevant for my model explainability is what r squared is talking about. Is this clear? You have to understand this to understand the next one. Give me a thumbs up or nod. Yes. Okay, that, see, it depends on use case, business domain knowledge, and feature selection that we have talked about. Actually, we have not talked about it yet, but in when we did the data analysis part, we discussed some of the ways, different ways, right? One is Pearson correlation or Spearman correlation, basis on which you can eliminate the features. Okay, just by looking at the correlation, that's how you can get important features. Second method is variation inflation factor. There is something called a VIF. Using by calculating that VIF, you can get to know which factor is contributing, which feature is contributing to good VIF value, and you can keep those. Okay, another method is called recursive feature elimination, okay, or backward feature elimination. Nothing but first you're gonna predict with one feature, and you will see that if you see some improvement in the model prediction, then you will add another feature. Okay, this is forward feature addition that I'm talking about. So then you will add another feature, then test it again. If that doesn't give good performance, you will remove it, then go for the next one. So that way you will consider. Or recursive feature elimination is also there. Nothing but you will consider all the features in one go. In the first run you will consider all the features, then you will remove one feature, calculate, notice if there is a decrease in the performance or the improvement in the performance metrics. Okay, and whether then you will decide whether to keep it or remove it, then move on to the another one. This way you will do the elimination of the features. So various methods are there. We will again repeat all these things in feature engineering class. Okay, for now, so this way we can decide. Is that clear? Okay, all right. So this is r squared, and most importantly, remember r squared has a range between 0 to 1. 1 is the good number of r squared value, 0 is poor one. Okay, sometimes this is what I noticed in one of the time series problem also, that sometimes r squared can be negative. When it is negative, you should immediately stop doing whatever you are doing. You should go back to feature engineering. Okay, that means your model is making very bad errors. I mean, it's very terrible. Okay, you should not even have that model in the first place. So that, okay, this is again one of the interview questions. So one of them, one of the question would be, if your r squared is negative, how will you fix it? Okay, you have to say start from the feature engineering. Okay, maybe choose a different model, maybe check for overfitting and underfitting. Basis on that you can decide how your model is performing. And you should also, actually you should talk more about feature engineering only. recursive feature engineering, feature selection, okay, coming up with designing new features, and all of those things you have to do if R squared is negative. Okay, moving on. There is one problem with R squared. We talked about everything seems to be fine, but the problem is when you add the irrelevant feature, okay, then also R squared sometimes starts increasing. That is the biggest problem. So we have talked about the, if you again pay attention to the definition, R squared explains extent to which the variance is explained by one feature in relation to another feature. But what it is not talking about is basically what it's saying. I'll simplify. R squared is saying if you use 10 features, okay, how much of variance is explained by the model to achieve the target variable. Okay, that is what it's saying. But what it is not saying is, if I let's just say to the same coffee selling problem, if I say, okay, if all my customers start wearing red t-shirts, would there be improvement in coffee selling? Or if they start wearing different colors like black color or white color t-shirt or whatever, would there be improvement in the coffee selling? So that is what R squared is talking about. R squared will take a feature, try to calculate the variance and see if there is any relevancy between that feature and the model prediction, and then accordingly it will give you a number. But if you think about it, it doesn't make sense whether you wear black t-shirt or green t-shirt, whatever. Coffee selling has nothing to do with the t-shirt color, at least, correct? Uniform maybe is a different thing, okay, but the color itself has nothing to do with the coffee selling. So now these are irrelevant features. So R squared is considering irrelevant features also. Okay, that is what we are saying. So if I do a rain prediction problem and if I say people in that certain area are wearing a certain type of dress or certain color of dress, whether I'm predicting rain and including such a feature, then it's senseless, right? But in that case also R squared might increase, which is incorrect. That is the biggest problem with R squared. Okay, so this you have to know. That is why in order to fix that issue, adjusted R squared is introduced. Adjusted R squared, what it does is it penalizes. When every time you hear the word penalize, you understand lasso regression or ridge regression. So penalize means it will start decreasing the impact of irrelevant features. Okay, so it is very same calculations are the same as R squared, except there is a penalization happening to the model. So whenever additional features are added or irrelevant features are added, the model gets penalized in its prediction. Hence the variance that is captured is does not impact the model. Okay, or in other words, adjusted R squared, okay, it adds more independent variables which don't increase the explanatory power of regression model. Okay, so this way adjusted R squared tackles that problem. So its range is also 0 to 1, but closer to 1 is better. Okay, this way all these metrics that we have talked about, I will attach a link as well, please go through. Okay, so this way you have to explain whatever the regression problem you work on. Okay, and okay, I have added the reference link here. So this is how you use for regression, and we will look at do a quick look at classification also. But I want you to just take a breakfast break. It's already 10. Please come back at 10:30. Okay, we will continue. Sorry, yeah, we'll come back at 10:30 and we'll continue where we left off.